So today we will start with lipid metabolism, right? So lipid is the chief fuel reserve of the body, right? Lipids. They are the principal storage form of energy, right? Why lipids are preferred over carbohydrates as storage form and proteins over storage form? Anybody who can answer me? Energy stored in mostly the storage form is in the form of lipids, right? Not carbohydrates or proteins, or you can say glycogen, right? Why? One reason is this, that 1 gram of fat or lipids will generate 9 calories per gram of energy, and in case of carbohydrates and protein you will get 4 calories per gram, right? So that indicates that it is a more efficient source. Same amount of 1 gram will give 9 calories and same amount of 1 gram will give only 4 calories, right? So it will give more energy. One reason is that. Second reason for lipids is that they are hydrophobic and non-polar, right? So they will not use water with them to get stored, right? So they are concentrated form of energy, right? If you have to store the same amount of carbohydrate or protein, you will need minimum 2 molecules of water to store with it, right? Lipids, when you have to store it, you don't have to add water. But in case of proteins and carbohydrate, you have to add water, right? The volume will increase, right? Anybody who is 70 kg who can come to the stage, 70 kg weight. Suppose Arif is 70 kg weight, right? And there will be approximately 10 to 100 gram of 100 kg of fat will be there, right? But in order to store the same amount of glycogen or protein, the weight has to increase very more times. मतलब अगर इतना store करना है तो you have to increase the weight by minimum 20 to 30 kg. That's why, right? Or you can sit. And today's main topic is beta-oxidation. What is beta-oxidation? Anybody who can explain me? Beta-oxidation. The fatty acids are oxidized by beta-oxidation, right? What does beta mean? Beta means beta carbon is involved, right? So I am just writing a simple CH2, CH2, CH2 and COO, right? A simple linear fatty acid, right? So this is alpha carbon, this is beta carbon and so on, right? The oxidation at beta carbon is known as beta-oxidation, right? Oxidation of fats at beta carbon. This is carboxylic acid group. This one is alpha, this is beta. The oxidation at beta carbon is beta oxidation, right? There are other oxidations as well, as like alpha oxidation and omega oxidation, right? We'll discuss in the next class. Today we are going to discuss exclusively beta oxidation, right? And in beta oxidation we'll first discuss beta oxidation of even chain fatty acids, right? After completing this, we'll discuss beta oxidation in odd chain fatty acids, right? So first of all, we start with even chain fatty acids. Beta oxidation is oxidation at beta carbon for even chain fatty acids, right? So I am starting with now proper beta oxidation, and beta oxidation has 3 steps, right? Beta oxidation is broadly divided into 3 major steps: 1, 2 and 3, right? In the first step there is activation of fatty acid, right? And in second step, there is transfer of fatty acid into mitochondrial matrix, right? And for this we use carnitine shuttle, right? And finally, beta-oxidation proper. There is mnemonic for that is O, H, O and C. The four steps are O, H, O and C. 1, 2, 3 and 4. First step is oxidation, second is hydration, the third is again oxidation, and fourth is cleavage, right? And this first step takes place in cytosol, right? The first step takes place in cytosol, and this beta-oxidation proper takes place in mitochondrial matrix, right? And the activated fatty acid is not permeable into the matrix. So to transfer it into the matrix, we use carnitine shuttle in the second step, right? So this is the basic overview. Beta oxidation is oxidation of fatty acid at beta carbon, clear? So we have a fatty acid carboxylic group CH2, CH2, CH2 and R, right? So this is alpha carbon, this is beta carbon, right, numbering like this. So oxidation at beta carbon is beta oxidation, right? And this beta oxidation is broadly divided into three steps. The first step is activation of fatty acid, second is transfer of fatty acid into the matrix, right? And third is beta oxidation proper. This activation takes place in cytosol, and the activated fatty acid is impermeable to the matrix. So it is transferred via carnitine shuttle, right? When it reaches into the matrix, it undergoes proper beta oxidation, right? And beta oxidation has proper four steps. That is mnemonic is OH, O and C, right? O for oxidation, H for hydration, O for oxidation and C for cleavage, right? And for further, there are two oxidation, one is by FAD and second is by NAD, right? So you can remember the mnemonic FA and FAD. So first will come FAD wali and then NAD wali, right? Now you can remember beta oxidation is oxidation at beta carbon, right? It has three steps, right? First step is activation of fatty acid, right? And this fatty acid is activated in the cytosol, right? Later on, it is transported into the mitochondrial matrix for further beta oxidation proper, right? But it is impermeable, so it is carried by carnitine shuttle, right? And in beta oxidation proper, we have four steps. OH, the mnemonic is this. And first step is oxidation, second is hydration, third is oxidation, and finally is cleavage, right? So I will start with the first step, that is activation of fatty acid, right? So चार बच्चे आना. So first step was, there were three steps, right? So first step was activation of fatty acid, right? So I was sitting there. The first step is activation of fatty acid, and it is taking place in the cytosol, right? The fatty acid is activated, right? And this is orange membrane, right? And this activated fatty acid is impermeable to the, this is inner mitochondrial membrane, and this is finally our matrix. The beta oxidation proper is taking place in the matrix, right? Now you can understand in 3D, the activation is taking place in the cytosol, right? When the fatty acid is activated, it is activated as this molecule, acyl-CoA. The fatty acid is activated to form acyl-CoA, right? And this acyl-CoA is impermeable to the matrix where proper beta oxidation is going on, right? So what will I use? I will use something else, this carnitine as a carrier, and this step is done by carnitine shuttle, right? When acyl-CoA and carnitine, acyl-carnitine will form, it will be permeable through here. I will come into the matrix, So this is your proper matrix, right? Beta oxidation is properly going on here, right? ठीक है? The first step was activation of fatty acid. Second is transport of fatty acid into the mitochondria, and the third is beta oxidation proper in the matrix, right? And this is the steps of activation, right? So first of all, you need screenshot. You can have photograph of that. So we have a fatty acid. We are now doing the first step, right? The first step is happening where, in which compartment? Right? The first step is activation of fatty acid. These all are three steps of beta oxidation, right? The first step is activation of fatty acid, right? So we have a fatty acid, and it is activated by to form acyl adenylate, and finally forms acyl-CoA. And ATP is used and pyrophosphate is released, right? And the enzymes are thiokinases, right? This is the first step of beta oxidation, that is activation of fatty acid, right? We have a fatty acid. It undergoes reaction by thiokinase in the presence of ATP to form pyrophosphate. This reaction is a irreversible reaction, right? This is irreversible reaction, and the fatty acid is activated to form acyl-CoA, right? And this acyl-CoA is activated, but it is impermeable to the mitochondrial matrix. Proper beta oxidation is happening in the mitochondrial matrix, and this is our activated fatty acid, right? So it has to be carried from this compartment is cytosol, and it has to be carried out into the mitochondrial matrix, right? To carry it from the cytosol into the matrix, we use the second step, that is our carnitine shuttle, right? Carnitine shuttle, right? So this is first step, activation of fatty acid. Now we start with carnitine shuttle. I delete it, right? So we have three compartments: cytosol, right? Then we have inner mitochondrial membrane, and then we have matrix, mitochondrial matrix. These are three compartments, right? And we have activated in the first step we have activated the fatty acid, and fatty acid is activated to form acyl-CoA. This is activated fatty acid, but it is not permeable into the mitochondrial matrix, right? So in order to carry it inside, we will use second step, that is our carnitine shuttle, right? So what will happen? Acyl-CoA will form attached with carnitine, right? And enzyme is CPT1, right? And we'll get CoASH and acyl carnitine. When carnitine and acyl group forms acyl carnitine, it is permeable into the matrix, mitochondrial matrix, right? So this activated fatty acid, acyl group, on combining with carnitine will form acyl carnitine, and this acyl carnitine is permeable into the mitochondrial matrix from the inner mitochondrial membrane. Now it has reached inside. It is acyl carnitine, right? It again combines with, here the enzyme is CPT 2, right? And CoA acid, and again we'll get carnitine and acyl-CoA. Now this acyl-CoA is free now, and it has reached into the matrix. This is the complete second step, right? So let's do it physically. Aao bachcho dobara. So this was our first step, right? It was activation of fatty acids, right? And in activation, we form fatty acid to form acyl-CoA, right? And we are having this acyl-CoA, right? It is our activated fatty acid, right? But they are very strong. This membrane is very strong. This is not allowing me to move inside into the matrix where my final goal is to undergo beta-oxidation, right? So I will use some bouncers, right? Name of the bouncer is, or enzyme you can say, it is carnitine, right? It will smoothen my work movement into the matrix, right? So this was our cytosol, this is our inner membrane, and this is our mitochondrial matrix where proper beta oxidation is going on, right? So I have activated a fatty acid. Activation forms the acyl-CoA. The fatty acid is activated to form acyl-CoA in the first step, right? But this is not permeable into the matrix. So what will use? Carnitine, right? Carnitine will come, and the third one is the enzyme CPS, carnitine palmitoyl transferase 1, right? So hold hands together. तीनों ने हाथ पकड़ ली. Now they are three. Now they can move inside into the membrane. इधर चलो अब धक्का मारो उनको, right? So they are going inside into the चलो. They are moving inside into this compartment. This is our mitochondrial matrix. So this is our mitochondrial matrix, right? The fatty acid was activated. Where is acyl-CoA? So this was acyl-CoA, right? It was activated and brought here into the matrix, right? Now it is activated. Now it is a further 4 steps I told, है ना? So ये 3 थे, तीनों अंदर आ गए. अब ये एक्टिवेटेड फैटी एसिड है हमारे पास, acyl-CoA अंदर आ गया. कैसे आया? Carnitine palmitoyl transferase 1, right? This one. And acyl-CoA was activated fatty acid. And this compartment is, yes. So this compartment is our cytosol. Show them na, cytosol. That is, you see them in the 3D, right? This is cytosol. This is inner membrane. And third one is our, clear? You are watching it in the 3D, right? Now we have activated fatty acid. That is our acyl-CoA, right? Now it is not permeable into the, it is not permeable into the matrix, right? So we used enzyme कौन सा? Carnitine phospholipid transferase 1. तो acyl-CoA, acyl will combine with carnitine to form acyl carnitine बन गया. Now it is moving inside into the matrix, and in the matrix see CAT2, the second enzyme. It will again break acyl carnitine, which is brought inside, and carnitine, this girl, will go back again into the our cytosol, and it is regenerated, right? Clear हो गया सबको carnitine shuttle? डायग्राम याद रहेगी, 3D पे भी याद रहेगा, है ना? अब हम करेंगे 4th step. और this in this compartment, this which is, ये अभी भी yawning करी मेरी क्लास में, lack of, right? This is our final step, that is mitochondrial matrix, and beta oxidation properly going on here. What was the mnemonic? OHOC. The first step is oxidation, and the second step is hydration. Third step is oxidation, and fourth step is cleavage. Right? So this is just simple beta oxidation. Is it difficult now? It approximately takes more than 10 pages. Just simple as the back of hand. Just try to remember this in your mind map बनाओ ना इसका, right? अब इसके 4 स्टेप्स आगे इसको डिटेल में करेंगे, बाकी सारे भाग आप टक्कर यूज करेंगे. बैठो नीचे सारे. So we'll use 4 steps. कंपार्टमेंट हमारे पास आ जाएंगे 4. Now we are discussing only matrix because we are doing our third step, that is beta oxidation proper, right? अब कैसे करेंगे? Just see the steps, right? Mnemonic was O, H, O and C, right? First is oxidation, second is hydration, third is again oxidation, finally is again cleavage, right? बेटा बैठ जाओ अभी नीचे, टक्कर तो भी रुके, बाकी जाओ नीचे, बैठो अभी यहाँ बैठना, बैठ जाओ, yes. So beta oxidation has 4 steps proper. Where it is happening, where it is going on. मैट्रिक्स वाला किसके पास है? ले तो नहीं गया कोई? Yes. आ जाओ. So this is our step 3, right? Third step is going where? In the matrix, right? And third steps have 4 parts. One is oxidation. Second is again hydration. Third is oxidation, and finally is cleavage, right? And I told in starting, this is even chain. Even chain fatty acids are using, so end product will be 2 carbon. And if we are using odd chain fatty acid, the end product will be 3 carbon. Right? Now I explain the steps. आप बैठो बच्चे. Now see, previous step, first step was activation of fatty acid. The fatty acid is activated to form acyl-CoA, right? And this acyl-CoA is impermeable into the matrix, right? We use this pink one, carnitine transport system, right? Through it is transported inside into the matrix, and this is proper beta oxy. First step was oxidation, OHOC. First step is oxidation, second is hydration, third is again oxidation. नहीं आ रही पानी पी किया. Then finally is cleavage, right? So first step क्या है हमारे पास? Acyl, right? The steps are 1, 2, oxidation, hydration, oxidation and cleavage, right? The first step is activation, and then it transported into the matrix by a carnitine shuttle. Second step, and we have now activated fatty acid acyl-CoA into the mitochondrial matrix. Third step. So we have acyl-CoA. The first step is oxidation. We use the enzyme acyl-CoA dehydrogenase, right? So we'll have, मैं डायग्राम इसका रिएक्शन बना दूं. Right? In the first step, we use oxidation, right? An enzyme is acyl-CoA dehydrogenase, and this reaction requires FAD, and it is converted to FADH2. And I already taught in the ETC class, during FADH2 how many ATP are produced? 1.5 ATP, right? So this was our acyl-CoA. Then it is converted to trans-enoyl CoA, right? So I told beta carbon will have oxidation. So what will happen? So here double bond is introduced, right? And coenzyme is FAD, it is converted to FADH2, 1.5 ATP is produced. The enzyme is acyl-CoA dehydrogenase, right? Now we have trans-enoyl CoA. Again, the second step was hydration. Hydration means you will add water. Water is added. So what will happen? We will have double bond hydroxy group. So how? Hydration is done, so hydroxy group is introduced here. In the first step there was oxidation, and we use FAD, FADH2, and double bond is formed, this one. In the second step is hydration. Hydration means you are adding water. So water is added, we'll have hydroxy group here, the double bond is gone. And after that, what will you get? Tell me. Third step is again oxidation. Third step is again oxidation. And what will you get? Beta-ketoside-CoA. You will have two keto groups. Right? You will have two keto groups. This is our beta-ketoside-CoA. And what will you use here? NAD, it is converted to NADH plus H positive. And how many ATP here? 2.5 ATP are produced, right? And final fourth step is cleavage. You have 4 carbon fragment. You will get acyl-CoA and plus acetyl-CoA. And acetyl-CoA will go where? Into the TCA cycle. Hope you remember TCA cycle by now. And this acyl-CoA is again going back here into the first step, right? So total how many steps will undergo? 7 cycles. Total 7 cycles will occur, right? At the end of cleavage, you will get acyl-CoA and acetyl-CoA. Acetyl-CoA will enter TCA cycle, and this acyl-CoA again enters the first step. It happens in the matrix where activated fatty acid is there, and for total number of 7 cycles, we'll get our proper beta oxidation done, right? So let's discuss now bioenergetics. Remember, we use FAD here and NAD here. FAD gives 1.5 ATP, NAD gives 2.5 ATP. Hope you remember the rotary model we discussed. In here only one compartment is not used, here only 2 compartments are used. That's why 2.5 and 1.5, right? Now let's discuss bioenergetics. See the diagram. This is. So I told you that there are total 7 cycles, right? So the 4 steps was 1, 2, 3, 4. Oxidation, hydration, then again oxidation, then cleavage, right? First step oxidation was induced by FAD, and this was introduced by NAD, right? And this gives 1.5 ATP and this gives 2.5 ATP, right? So total 7 cycles are there, right? So first FAD 7 multiplied by 10 point 1.5 multiplied by 7, how much is there? Please calculate. 10.5 ATP, right? Then in the third step you use NAD. How much? 2.5 multiplied by 7. Please calculate how much? 17.5 ATP. Clear है सबको? 17.5. During FAD we produce 1.5 ATP. The first oxidation. In the third oxidation we use NAD, NADH. We form 2.5 ATP. And there are total 7 cycles. So we multiply them with 7. Right? So we'll get 10.5 ATP and 17.5 ATP. Right? And in the first step of cleavage, we form acyl-CoA. And one acyl-CoA gives how many ATP? 10. And their total produce 8. So we'll get 80 more ATP from acyl-CoA. To calculate them, कितने बन गए? 90, 108. Please tell me if I am not wrong. 108, है ना? 108. Total 108 ATP are formed, and only 2 minus. There, the first step was activation of fatty acid, and we used pyrophosphatase reaction. So 2 ATP were consumed, minus 2, and total 106 ATP are produced during oxidation of palmitic acid. Right? If you are now not able to calculate ATPs, why? Because you are not studied the ETC chapter. We did rotary model. We move into different segments where 4 plus 4 plus 2 कितना था? 10. 484 H पॉजिटिव से कितने बंदे थे? याद करो वो सारा, तभी ये आएगा. Right? Any doubts left? Please tell me. Any doubts left in beta-oxidation? And this is palmitic. How many carbons are there in palmitic acid? Just tell me, it is even chain or odd chain? It is a even chain. Right? So end product was 4 carbon acetyl-CoA and acyl-CoA. But if you have a odd chain fatty acid, odd chain, what will you do? If you have a odd chain fatty acid, then product will be 3 carbon. What is 3 carbon? Propionyl-CoA. In place of acetyl-CoA, you will get propionyl-CoA. From here onwards, the metabolism will be different, right? Just see diagram. I don't have it, so I will make it. Okay. So during oxidation of odd chain fatty acid, the end product is propionyl-CoA, right? And it undergoes carboxylation reaction via propionyl-CoA carboxylase, right? So what will you get? What will you get? You will get dimethyl malonyl CoA, right? And it is then converted into L-methyl malonyl CoA. Then via B12 reaction, it is converted into succinyl CoA. And succinyl CoA is substrate for TCA, so it will enter TCA via here. In even chain, we use form that product, that is acyl-CoA and acetyl-CoA. Acetyl-CoA can enter the TCA cycle from the beginning, right? But in odd chain, we will get 3 carbon propionyl-CoA. Propionyl-CoA undergo carboxylation reaction via propionyl-CoA carboxylase to form dimethyl malonyl CoA, then undergoes racemase reaction to form L-methylmalonyl-CoA. Then in the presence of B12, you will get succinyl-CoA. Succinyl-CoA is metabolized via, it is a component of TCA, so it will enter TCA. So if you have a even chain fatty acid and you have odd chain fatty acid, which will be metabolized fast? Odd chain will take more time, na? Because it has 4 more steps, right?